Well, first, thanks, Mash, for the opportunity. Like, it's amazing to be here. Like, been talking with Mash for a long time, and this is a great space to discuss. And always, it's great to be speaking with great people and innovators and people that is interested in this time of technology. So that's something amazing to be here. So I will share my screen a little bit and thanks Mash for the introduction. So we'll talk a little bit about well, some introductions, because there is a lot of things to talk about here. There is a lot of data and information, and the first thing is like describe about a little bit of what it is the self-sovereign identity and what is being done in MiBA and QUARK ID mostly. And then I will go on a review. Well, here is a little bit of my background, was mostly what Masha says. I'm been working with the government of Buenos Aires, been working with a lot of different types of projects and technologies. Right now, I'm coaching and leading some projects in the government of Buenos Aires that are more linked to digital identity and the incorporation and the integration of these systems in technology mostly. So what is digital identity? I don't know how many, I will try to check on the meeting. So how many of you know about self-sovereign identity? Can you reach your hand? Okay. And how many of you have been working on this and have been implementing that on real systems, or tried at least to implement that? Okay. So great. Let's start from that. And so, what is this digital identity, and why is it important for you to understand that? This is being shown. I don't know if it's being shown the entire presentation. Hopefully it is. But so for you that you can read here, it is what is this identity for? So we are exposed to get information, and our data is being manipulated by a lot of entities and a lot of companies that you share this information all the time. You validate this information. You use it for public systems and private systems. So what happens is what this digital identity, it is not what you do online, is not your fingerprint on the network. But it helps you to get a good point of reference for your digital reputation and your digital footprint, and also helps a lot in terms of having you the control over your data, right? Like the control over what your data is being used for, and how do you choose to share your data, right? That's your digital identity in terms of abstract implementations. And we use this all the time, like when you use Google, when you use all your fingerprints, when you use facial recognition and your iPhone. So all these systems are using your digital identity, and all englobe everything in this area. But it's not being used for like any practical way in more than access things and implementations. In terms of you're using Google for signing, or you're using your fingerprint, so you can. Oh, sorry, I'm going to send this. That's it. And you're using other systems that use that information, but they all give you the data for themselves. So they store all your information. They know where you are. If you go on Google Map, you can search and see all the places you have been, and the times and the patterns and everything. So that's kind of scary for me, at least. And it's very concerning on how these companies use. I'm not saying Google is evil, although, but how these companies are using our information, and how this impact in our lives, in the way we think, in the way we buy, all the things. So for that thing, it's the base. It's the workspace and the framework where QUARK ID was developed for, mostly for an open source project. I will share that too. I will share that in a minute. But an open source project for people to recover their identity, to recover the access to the data, and the rights for them to share the amount of data they want, right? So Buenos Aires has launched so far last year the first digital identity and the blockchain-based identity for their citizens. We have over 3.6 million users in the My Buenos Aires platform so far in a decentralized way in using DID. It's DID. It's the standard identification system defined by the W3C. That is the standards for decentralized identity, communication protocols, and so on. So I will review that in a second, though, for more technical ways, and also we have some Q&A later. So right now, the app My Buenos Aires is being used for citizens to get, store, and manage their identities. They can like access and request documentations, request like birth certificates, marriage documentation, and also a lot of other implementations. So far, I'm building a system for them for the access to the buildings, the access for the government buildings and events, and also doing an open source development for verifications and other implementations that they are also going to be open source for everyone to be building on. So what's the blockchain behind this? Well, so far it's powered by CitySync, and we are also going to discuss that in a little bit. CitySync is a blockchain that helps you to prove different kind of data over with the zero knowledge proofs, allowing you to prove things without having to share all the details, mainly on the blockchain, and helping that to maintain you with the data private for you to implement and data to be in use. So hopefully I have explained myself so far the introduction. I don't know if there is any doubt. Let's request that after the presentation, though, and let's continue. So what is this digital identity and city management? So these systems allows the citizens to have more secure information. And how is the basic flow? So there is a ID holder. All the citizens are ID holders. They have their credentials in blockchain that are issued by a government entity or a company or a private or a public company. There is a blockchain base where that system is the base of all the interactions, and there is a process of validation, right? This process of validation checks the credentials keys and checks the blockchain encryption information, and it verifies the correct way of that technology, right? The correct way of implementation that is not being a generic credential, is not being issued by anyone, whatever could issue things. So they check the validity of that, and they have this. This is what it is known as the triangle of trust, basically. And that you have your ID, you have your credentials, you have your citizen, and you have the verifications, and you use that blockchain in the middle to do the validation and the verification of the information. So what this helps in, and the main benefits are to simplify administrative procedures, reduce fraud, and increase privacy for citizens. That's the key goal here. And also them to reach and get all their own data and choose what they are implementing. So implementation so far are being done in education, healthcare, transportation, access to digital certificates so far in the MiBA application. And yeah, that's a little bit on that. I'm checking my time, so I don't want to pass on that. So what is this system for? So what kind of companies or agencies or institutions can get the most out of it? So this is for government agencies and institutions. It's a blockchain-based digital identity solution designed for public and private sectors. It enables secure and instant insurance and verifications of official credentials. Issuance is instant issuance. Sorry. Um, so how it works? It has a unique registration. The citizen and the staff can register using their physical ID or existing data. So all the databases that has the government or the companies that have their users database, they can translate that to the blockchain using these systems and doing a migration script and coding a little bit on that. Also, there is everything on chain, so credentials are issued on chain, are immutable. They have an immutable identity token to generate and store that on the blockchain. So yeah, the credentials are being signed in this way. So it's a different kind of token. It's not like the default ERC20 or it's a specific SSI token. It could also be another thing. It depends on the project and the development and the extension that you want to do later on too. And it has a real-time verification. So you can use the system, you can use the application, and you can build your own wallets for identities. And the protocol is open. So the ID protocol from Web3 works with a resolver, a general global resolver, that you register the method, for example, the did QUARK ID or the did Scotland, for example, and you can build on that identification protocol and use that generic system to be approved and validate over the entire globe. So this helps a lot. How you can see the way that you interoperate information through countries, right? Like so far, when you travel, for example, to another country, you have to validate your over the migration process, in that you have to share your documents, you have to share like your fingerprints and all the process. But it's been so far done new updates on the express processes that you can use, like digital credentials, yeah, or facial recognition, and other technologies in borders. But this technology could be, for example, applied to get an official government document and certification and apply and check that in the border. So you can directly issue credentials from your government and then use it in another country to validate your entrance. And for example, to something like that, that could be a real world application that is it's being worked here in Argentina and in Latin America too. Like so far, there are initiatives in Ecuador, in Colombia, and other countries that are tending to go to these tendencies. Um, and also there is the benefit for the public sector, right? So the government has to, and the public agencies and the institutions have to have everything regulated, right? You have to be auditable, you have to be real strict with your data, with your security, with your transparency. So those are the key benefits for the sector. So you get security because this is cryptographic. So everything is not on paper, and it helps you with crypto proofs to validate the keys and the validation for the issuance and the issuers. It gets you transparency and traceability, so you can trace all the implementations and the issuance on the blockchain. Yeah, you can check or not to have the information. It could be it would have parts off chain if you need like extra privacy, so you don't have to put all your data on the blockchain. You can have like special centralized documentation access to that with some Oracle like Chainlink or other company. and check that the information and validate that with the credentials and do more cross data and traceability too. Also helps you on operational efficiency because it helps a lot of time. Like previously, you have to request documentations and you have to present and validate that documentation with lawyers or assert that the documents that you are presenting are valid in between agencies and institutions, because more of the time they don't share that information, right? Like that databases that you have are not like interconnected in all the process. So it helps a lot of time and saves a lot of time on that for people that has to be doing this process manually. Also in the interoperability, it helps you integrate that with other systems. Like in Buenos Aires, we have systems for the official employees of the government, like mobile applications, service portals for the citizens, and so on. So for you to try, I think you will be able to scan this. We'll try to myself. So here you can download the QUARK ID application. So you can check if that's okay on well, you can get like your credentials so far. You can download. If not, let me check and I will share the correct link for that. And you can try this on Google Play or Apple Store. You can download the open source wallet of QUARK, and also there is an official credential that institutions can like get access to that. If you are an official entity and want to your yeah the link doesn't work, I think. So I will share. Let me check if I can share. Well, I will share the links later on that. So also, oh no, just one more thing on that. I will share. What I was trying to check is that, for example, if you have official entities, for example, the government of Buenos Aires is listed on the official entities that you get access in the open source wallet. So if you have like the government of each city or specific companies or implementations can be done, and the user can auto issue their own credentials and save that credentials there. So for you to check a specific credential, for example, this is how a credential looks like. That's it. For example, in the terms of your own data, and then when you access specific uh, places, you can present your specific credentials. Like the system can request you to present multiples or just one credential, and you can, for example, go across a specific building of the government. So that's one thing that could be implemented. So going more into that's like there is a lot of information. So let's check a little bit on the website for that to be more clear. In this is the open source website for QUARK ID. Like you can find it on quarkid.org, and there is this is here's like the more information on the credentials, the implementations, but what it helps you a lot to understand if you are a developer, and you can get more documentation here on how to implement this for your implementations. So this is specific diagram on how this can be interoperable between entities. Like you can validate, for example, a bank credit because you are requesting, for example, a credit for a car, and you need to prove a valid credential for the bank that you are available for that, or you have to put a specific education certificate to get that, or to get approved by an organization flow to enter to that job. You can start interoperability without having to share their specific data and their databases, and that allows you to have digital trust. Right, that's the main goal. And right now, QUARK ID is multi-chain, so it's been implemented by ZK-Sync, Polygon, Ethereum, and Rootstock. There is open to integrate to other chains, to our other protocols, and yeah, it's main of it's been developed by the government of Buenos Aires and a partner ecosystem too that is developing this for more. So yeah, that's mainly here on about QUARK, an introduction to that. And if you are really wanting to have more information, that you can get the documentation. Here you will know a lot, and you will find a lot of specific technical details on how these DIDs work, the specific W3C implementation, the trust over IP implementation and technology, and all the foundation on the decentralized identity. In a more technical aspect, for example, if we go to a specific technical implementation, how this is done, this is a specific doc could get shared to of ZK-Sync documentation on how this works in terms of layers. Like you can have the operations and the nodes on QUARK that are being used in and they're connecting information through these decentralized web nodes. And the user can have access to the wallet and verify their QR, everything over a QR data, and sharing their credentials on that. So, for example, here in the Buenos Aires system, it's implemented over a data center for the government. It has a front issuer that emits these credentials and acts as a middleware and a middleware verifier for the users, connects the information to the backend, and also makes the login process for my Buenos Aires systems, allowing the credentials in QUARK ID blockchain to be the Google for the government system. And yeah, basically under the hood, you are working with these DIDs and polling messages from decentralized nodes. It's using the QUARK protocol and using the interoperability and the proxy and the API on ZK-Sync on that phase. You have to store your credentials too. Like you have to have like a specific server to handle the credentials that are being issued. You have to have a specific API to distribute that information between your applications. And also you can have in infrastructure like Google, for example, this is being used so far for the cloud if you're using servers that are being used to store that information. So yeah, I think I just pass a little bit on the time. I don't know much. I'm okay on that.
Right. Thank you so much. We just leave some time for questions now. So I'm gonna basically okay. So like just some those practical flaws and limitations that centralized identity systems have. For example, someone could be doing data. I'm going to list just like the normal ones. There is basically like fragile. Someone could break in, steal millions of credentials, and you can't buy insurance against that. That's number one. Two, someone could be doing the data linkage. There's like every time you do an API call, they could basically save those API calls, link the data, and like sell the linked data. And also the third one, like you have to maybe pay a fee, like to if it's closed source, you have to pay a fee to some base, the centralized company owning the centralized infrastructure. So these are just there are many more of this. So can you just clarify those three flaws I mentioned? How does does this kind of like solve all those three issues? Like people ask, okay, what's the point of having a decentralized identity system?
Okay, so the way this communicates, for example, addressing first the last one in the question of if someone could be in the middle and access that information. and store that and use. For example, this connects directly over webhooks and sockets. So if you request a verification, for example, if you have a QR code connecting to a specific system, for example, I will talk about a little bit of the system that about events and buildings of the government buildings. So you can have QR codes in the entrance doors for those places. So each door has a specific QR code. So you go with your official credential, you scan that, and the doors open. That shuts a specific request from the wallet or of each user to a specific system. It doesn't go back over HTTPS request, like it goes directly to the system. So you just get a specific verification over socket about the validity of okay or not in your wallet and the QR code that you are um, validating. So there is not being shared data on that, and the verification is being done directly on the server and the system. So the wallet is smart enough to get when you issue specific credentials, each credential is mapped out to specific systems. So you have, for example, um, you issue the credentials for the university, and only the server of the university will receive those message, like will receive the verification messages. And if that server is down, the credentials goes down, for example. So it's all this being mapped to each specific implementation. So there is not data being sent over and received over HTTPS or requests. So that makes you have more extra security because you are not sharing data. There is not a man in the middle that could stole your information and could abuse on that. In terms of the other question was about over hundreds of millions of requests, right? Like what happened when you have hundreds of millions of requests. So each server, each implementation is being done by each institution. So you have to pay for your own infrastructure, right? And you have to build your own in terms of infrastructure to address all those requests, right? Like it is a little bit expensive if you are using specific private storing data. Like for the government, we have to save specific data for privacy users. We don't put all the identity on blockchain. So that information is being saved in specific vaults. But you can have, for example, IPFS documents and can save a lot of space and money on those kind of systems if you are building something more open that don't require like hundreds of servers and redundancy and integrations. But yeah, it's if you are thinking about it in a great scale, like you have to first we have specific cybersecurity agency that has AI and other implementations on the network that allows you to do some load balancing on the implementations and check if you are doing some attacks or a DDoS attack. You have to uh, uh, work out that solution for each system that you build. That's a specific user implementation. But that is expensive if you are aiming for millions of users.
Okay, let's see if anyone has any questions. Yeah, so please come forward here to ask the question of the lab.
Hi. So my question is about the system. You see, like when you submit your identification, does it only work with the companies that support this kind of like ecosystem, or like so? What's the technical knowledge has to kind of like develop in terms of like API usage for the companies to adopt it. So for example, if like the Latvian government wants to implement this scheme, like can they do it? What's like how hard it is for them to implement? And also if it's like the sport league wants to have some kind of like ID check for the players, is it also
Yeah.
like the customer of this system?
Yeah. So the just a little bit again on the question is uh, how it is the technical implementation for organizations, and how they check over each issuance and all issue credentials, right? Like how they validate between them. So for that, I will share a little bit on the specific documentation, like over GitHub. You can find specific implementations done so far. So all this is open source. So here you can, if you go on GitHub and check SSI QUARK ID, you will find all the repositories and the documentations that are open for everyone. Here is the license implementation and the white paper for everyone to check. And there is here you have a specific guide on all the components that you need to build these specific systems. So you're required to have a specific API for the blockchain that you are going to use, a specific proxy that is going to redirect information, a message manager, a decentralized web node, and a mobile agent that could be your a React Native wallet that you can extend and you can use, for example, to build your own wallet, or as an example of a template. So here you have all the components. It's I won't say it is super hard, but it's complex in terms of development teams. You have to have a multidisciplinary team of mobile developers, backend developers, blockchain developers, DevOps, and frontend. At least one of each to implement that in a large scale project, right? And you have to have the servers, or at least open, if you are going to use open servers, or those implementations need to be done so far on that. For example, if you want to check, I will go to one of the issue. Here we have a quick start node, so that could issue credentials, for example, for you to see more specific details in each project has this kind of documentation on them, so you can just download the project, run the installs, and check on that. So here is a little bit more on implementation, how all the checks on how to implement this identity specific method. You can check how the network works, all the implementations on the mainnet of the CKSync network that you need to interconnect that, and the testnet too, if you need to do an explorer on that. All the endpoints information and resolve information. Just I wanted to go over a simple one because this is a little bit complex. But here you have like a lot of open source projects that we have uploaded and launched there. So you can use that as a template for each implementation. And also, let me check here. This a quick emission verification system. So it works over Node, npm TypeScript, and type Node. So you need to build, download, clone the project, and everything. And here is, for example, an implementation in terms of the KMS storage. The KMS storage is like the basic system that you require for that, because this is the key management system that is going to save and store all your credentials and all your IDs, and it's going to save that into your servers, basically. So this is how you can you just install the library, the QUARK ID library, KMS core,
I suggest we're running short of time. We're just going to finish with one final question. And then,
Yeah.
So, Ian, if you'd like to come forward.
So if I get it right, the mobile agent will upload the copy of the credentials onto the server, and it's the server that generates the zero-knowledge proof. Is that correct?
Yeah, like the zero-knowledge. Sorry, go ahead.
I was just curious. Once the zero-knowledge proof is then generated, is the original document then removed from the system, or do you have to keep it stored still on the server?
Yeah, like for example, you can choose on that. You can choose to save the document or not. It depends on the system and the specific requirements that you do. Each time that you generate a credential, it generates and it issue you the code and the proof of that and the response of each proof. So you can choose that to save that or not. If you we choose to not save that information, each validation and proofs, because we are more connected to the decentralized way of doing the things and not storing all the interactions. But we do save the validity of the proofs. So you can check, for example, if each zero knowledge has a specific sign, signatures. So you can check those signatures and check if those are being done by a specific issuer or a specific verification in a specific institution, and that can be saved without compromising the data or the information.
Amazing.
Sorry for I know there is a lot of data to assimilate, and would love to have more time to share that. So yeah.
Thank you so much for sharing this new paradigm of building identity systems. So it might take some time for people to get used to this new way of thinking, new way of building. But thank you so much for showing us how to do it. So we thank Lucas joining us from Argentina.
Yeah.
Thank you so much. Bye-bye. Bye.